I thank you all for watching my videos all these years. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of June 2023. This question is from the section Linear Algebra and it is related to the extension of a given set of vectors to a basis in an inner product space. This question is from the part C, which is a multiple select question. There can be more than one answer. It carries 4.75 marks. The question ID is 704077. This question is suitable for all these examinations. Right. The given question is, let V be an inner product space, that is, a vector space equipped with an inner product. Let V1, V2, V3 belongs to V be an orthogonal set of vectors. Which of the following statements are true? We are given four options. Option 1, the vectors V1 plus V2 plus 2V3, V2 plus V3, V2 plus 3V3 can be extended to a basis of V. Option 2, the same above vectors, three vectors, can be extended to an orthogonal basis of V. Option 3, we are given another set of three vectors here, can be extended to a basis of V. Option 4, in a similar manner, another set of three vectors are given, can be extended to a basis of V. It's a very simple question. And let's now discuss the solution of the problem in detail. We have an inner product space V, that means a vector space V equipped with an inner product. Right. We are given three vectors V1, V2, V3. We'll assume they are all non-zero because we are talking about orthogonal set of vectors, and this V1, V2, V3 should be non-zero. Given the set V1, V2, V3 is an orthogonal set of vectors. That means every pair of distinct elements, distinct vectors of the set is orthogonal. So that means Vi, the inner product of Vi with Vj is 0 for I not equal to j, where Ij belongs to the set 1, 2, 3. They are pairwise orthogonal. That means every pair of distinct vectors of the set is orthogonal. Agreed. Agreed. Let's call upon a result. This result perhaps we have studied in our BSc class. Every orthogonal set of non-zero vectors in an inner product space is linearly independent. That means if your set is an orthogonal set in an inner product, then those vectors are linearly independent. Therefore, the set consisting of V1, V2, V3 is an orthogonal set implies the set consisting of V1, V2, V3 is linearly independent. I am sure you are familiar with the definitions of linear dependence and linear independence in a vector space. Let's call option 1. The vectors V1 plus V2 plus 2V3, V2 plus V3, the third vector V2 plus 3V3 can be extended to a basis of V. When can this be extended to a basis of V? If provided these three vectors are linearly independent in V. So these vectors can be extended to a basis of V provided they are linearly independent. Right. So we write a linear combination. Alpha times the first vector plus beta times the second vector plus gamma times the third vector is equal to the zero vector of the vector space. Right, where alpha, beta, gamma are scalars. Now write this as alpha times V1, the coefficient of V1 is alpha, plus the coefficient of beta V2 is alpha plus beta, plus the coefficient of V3 is 2 alpha plus beta plus 3 gamma times V3 is equal to 0. Is a linear combination of V1, V2, V3. What are V1, V2, V3? They are linearly independent. This implies alpha is equal to 0, alpha plus beta is equal to 0, 2 alpha plus beta plus 3 gamma is equal to 0 because V1, V2, V3 are linearly independent. Take alpha is equal to 0, substitute in the second, you will get beta is equal to 0, alpha is equal to 0, beta is equal to 0, substitute in the third, you will get gamma is equal to 0. This will imply alpha is equal to beta is equal to gamma is equal to 0. So the linear combination is 0 implies these scalars are all equal to 0 will imply those three vectors are linearly independent and hence can be extended to a basis of V. Thus the option 1 is true. Right. We move on to the second option. Option 2, the vectors, the same vectors can be extended to an orthogonal basis of V. When this can be extended to an orthogonal basis, provided these three vectors, the set of these three vectors is an orthogonal set. So these vectors can be extended to an orthogonal basis of V, provided the set consisting of these three vectors is an orthogonal set. That means they must be pairwise orthogonal. So first and second orthogonal, second and third orthogonal, first and third is orthogonal. First of all, let us see the first vector and the second vector, are they orthogonal? Now, the inner product of the first vector with the second vector is equal to the inner product. When you take it, use the rules of the inner product. The inner product of V1, V2 plus the inner product of V1 with V3 plus the inner product of V2 with V2 plus the inner product of V2 with V3 plus 2 times the inner product of V3 with V2 plus 2 times the inner product of V3 with V3. Now we have V1, V2, V3. It is an orthogonal set. Therefore, V1 is orthogonal to V2. The inner product is 0. V1 with V3 0. V2 with V3 0. V3 with V2 is 0. Therefore, you are left with the inner product of V2 with V2, that is norm V2 square, plus 2 times norm V3 square. And what is V2? V2 is non-zero. Then its norm is greater than 0. Norm square. The norm square is greater than 0. 2 times norm V3 is greater than 0. Therefore, the sum is greater than 0. Therefore, it's not equal to 0. Thus, these first two vectors are not orthogonal. So the first vector is not orthogonal to the second vector. Therefore, that set consisting of those three vectors is not an orthogonal set. Therefore, this cannot be, those three vectors cannot be extended to an orthogonal basis of V. Okay? Therefore, the option 2 is not true. Right. Let's move on to the next option. Option 3. The vectors, these three vectors, can be extended to a basis of V. In this, we make an observation. The second vector V2 plus V3 and the third vector 2V1 plus V2 plus 3V3. When you add, you will get 2V1 plus 2V2 plus 4V3, which is 2 times of the first vector. So, observe that the first vector plus the second vector is 2 times the first vector plus the third vector is equal to 2 times the first vector. That means 2 times of the first vector minus the second vector minus the third vector is equal to 0. So here is a linear combination whose coefficients are not all of them 0. Therefore, these three vectors are linearly dependent. The given vectors are linearly dependent. Therefore, it cannot be extended to a basis. This can be extended to a basis if they are linearly independent, but they are not. Therefore, this cannot be. Therefore, these three vectors cannot be extended to a basis. Right. Move to the last option. So that's option 3 is not true. Move to the last option. Option 4. The vectors, first vector, second vector, third vector, can be extended to a basis of V. Right. It can be done provided they are linearly independent. Right. So, write a linear combination. So, alpha times the first plus beta times the second plus gamma times the third vector is equal to the 0 vector. Right. Write down the coefficient of V1 is alpha plus 2 beta plus 2 gamma. That is the coefficient of V1 plus the coefficient of V2 is alpha plus beta plus gamma plus the coefficient of V3 is 2 alpha plus beta plus 3 gamma is equal to 0. This implies these coefficients must be equal to 0 because V1, V2, V3 are linearly independent. So, the first one is 0, second one is 0, third one, these are the coefficients, zeros, because V1, V2, V3 are linearly independent. So, this is a set of three equations in 3 unknowns, alpha, beta, gamma, and it is a homogeneous system of linear equations. So, write down in the matrix form, A x is equal to 0. That is, A is 1, 2, 2, 2, 1, 1, 1, 2, 1, 3 multiplied by the column vector alpha, beta, gamma is equal to the column vector 0, 0, 0. So, what we will do is, now we are trying to find out what are the values of alpha, beta, gamma. Right. For that we take the coefficient matrix and reduce it to echelon form and study its rank. So, take the coefficient matrix A, right, 1, 2, 2, 1, 1, 1, 2, 1, 3. We make a elementary row operations, right. So, R1, R2 is R2 minus R1, thereby this becomes 0. R3 is R3 minus 2R1, then this becomes 0. Then this will become This is the matrix 1, 2, 2, 0, minus 1, minus 1, 0, minus 3, minus 1. Now make another row operation to make this element to 0. So that is R3 is R3 minus 3 R2, not R1, 3 R2. R2. There is a typographical error here, 3 R2. 3 R2. So that will be 1, 2, 2, 0, minus 1, minus 1, and 0, 0, 2. It's in the row reduced echelon form. Obviously, the rank is 3. When the rank is 3, 3 is equal to the number of unknowns alpha, beta, gamma 3. Therefore, it admits a trivial solution, namely alpha is equal to beta is equal to gamma is equal to 0. So, alpha is equal to beta is equal to gamma is equal to 0 because the rank of the coefficient matrix is 3 is equal to the number of unknowns alpha, beta, gamma. Therefore, we have only a trivial solution, namely alpha is equal to beta is equal to gamma is equal to 0. Right. Therefore, those given 3 vectors are linearly independent. Therefore, they can be extended to a basis of V. Thus, option 4 is true. So, summarizing all the options, the answer to this question is options 1 and 4. So, that is the detailed discussion of the solution of this problem. It is a very elementary problem. This is depends on linear independence and all that in an inner product space. And I'm sure it is definitely an easy question. I am sure that you have understood the solution of this problem. I thank you for watching this video. Now, please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Let's hope to meet you once again in another episode of learning. I wish you all the best. Thank you.